So now that we have this new tool of solving an equation that looks like a proportion by using cross products or by trying to undo, that we can keep applying. So what's really nice is if you have an equation that maybe you didn't set up with the idea of proportions, but it turns out that it looks like what I wrote here, a fraction equal to a fraction, or a ratio equal to a ratio, right? Then that means it wouldn't be equal unless the cross products were the same. So you can apply that idea to solve them. So these are just good ones to practice, number 5 and number 6. I would recommend realizing, oh, they're in the form of a proportion, so I can do the cross product. Okay. Write down what you get and make sure that every step of the way you have an equation. So I have 12.7 times 3 on the right, which is 38.1. But that is equal to what I got on the left when I did 0.02x. Keep writing equations, because these shouldn't just trail off to the side and turn into some confusing array of computation. Should keep organized. So now I'm dividing both sides by 0.02. You can draw that in, but that gives me my 190, I think it was, 0.5. Now make sure you check. Anytime you solve an equation, it's good to check. We could plug our number back in and then just take a look and see if the left side you could divide and see if it's equal to what you get when you divide the right side. You could check cross products. Just even in general, noticing that this 190 on the bottom is a lot larger than the top, and so 3 should also be the same amount of times larger than the 0.2 on the top. Maybe not obvious, but that should be true. If I do number 6, so try it out, pause the video and see if you get what I get, and then see if your work is organized similarly so that we can tell how you're solving. So I multiplied each cross product, and then I get on the right 8,500 times 5 is 42.5, and then, oh, I lost my x though. There we go. So you can tell that it should come out of maybe about 10, because 4,200 times 10 would be 42,000. So I'm going to guess close to 10, but not exactly. Divide the last answer by 4,200. And I get 10.12. It says round to the nearest tenth in the directions, so the next one wouldn't bump it, so I'll call it 10.1. So this one is a good one to check, because if you just do it by estimation, right, I can tell if I double 4,200, I get 8,400. So the top is about double the denominator, the bottom. And 10 is a little more than double 5. So that seems right. So I could check it in more exact ways, but that's at least a good idea that I'm right. Let's try this last word problem. It says, many small engines for saws, motorcycles, utility tractors, so even like my weed whacker uses a small engine mixture, and so you have to mix some oil in with the gas that you get. So if an engine requires 20 ounces, keep track, 20 ounces of oil for 5 gallons of gas. So if I did that per 5 gallons of gas, then, oops, let me fix my numbers. It's better. What am I really comparing here? Remember the words, I like to keep them in. So this was oil, and I'm comparing that to the gas. So it's an oil to gas ratio. That's often stated in the manual. Sometimes you can find it on an oil bottle, so they might give you some typical, small engine, certain ones, but they can vary depending on the engine. So what's the question? It says how much oil, so that means I'm going to need to know what the top is here. Oops. How much oil would be needed for 8 gallons of gas? 8 gallons. So I have gallons to gallons, so my gas is consistent. So if I get a value of X, I'll know that I wanted to keep it in ounces. Right? So as long as I keep the oil consistent and the gas consistent, I'm good to go. So it looks like 20 times 8 is 5x. So 160 equals 5x. And x will come out whatever you get when you divide 160 by 5. So 160 divided by 5 is 32. 32 what? Oh, remember up here I had it so that I didn't forget. It's not gallons, it's ounces. You don't need as much oil as you do gas. Even though the number's bigger. Okay, that's not a lot. 32 ounces. So, and that was oil. So there we have it. Right, so very simple, and that might come in handy. Now I'll scroll down here because this is a really big paragraph, but some of you might find it really interesting. It has to do with the aspect ratios on TVs. Like when you see some are sometimes like it doesn't fit right on your screen the way they filmed it because it's done with certain aspect ratios. And so it's good to read over this just for the interest. It's not a problem to solve. But read it over so you might like it. You can even try the problems right after. But that should get you going, get on the OCE, and I think that should be pretty smooth. So some of them are just solving the proportions. Get them done.